today's project is to fit a Dapol Semaphore signal to my layout, and it's a Dapol 4L001001 GWR home signal, lower quadrant, which in itself is no big deal at all. Fitting these, I'm not going to actually show you how to fit it because the instructions in them are very comprehensive, and if you want to see a video of how to put one of these on your layout, you could go to, I think there's several places to do it. The latest one was Jenny Kirk at Weir Yard put a video on how to do it, so I suggest you have a look at that. That's not what it's about. What it's about is actually automating this signal. And again, there are videos that will show you how to automate this, but my automation hopefully will be a bit different because I have a cunning plan. And here is why I need a cunning plan. This is a very badly drawn example of what's happening. On my layout, the signal will be on a branch line, and it's a single track, two-way working branch line. So normally you have a train coming towards the signal. Here is the signal. It clears, you go past, and the signals go back up again. You can automate that quite simply. I don't know what method you may have seen, but I shall be using one of these, which is a Heathcote Electronics Semaphore signal sequencer. Again, I'm not going to talk in detail about this piece of kit because if you want to know about them, then Heathcote Electronics have got an excellent website. I'll try and remember to put a link in at the bottom, and you'll see full instructions, full information of all their products, and you can find out about it. Now, the idea is quite simply with these is that the train comes this way, it goes over a sensor in the track, which is this bit here. This is the extended wire version, because you can put this under the track and have this quite a bit away instead of having to put the board up under the track exactly where you want it. So they're quite useful. So you've got the infrared detector in there, which triggers the board, which triggers the signal to come down. That little dot I've put in there represents a timer. It's an adjustable timer on the board, so you can decide how long you want the signal to clear for and then go back up, which is fine. No problem. What's so difficult about that? Because again, in the instructions for the sequencer, Heathcote Electronics will give you full information on how to do it. You don't need me to tell you how to do that. The snag is, this is where my cunning plan comes in, is that when you have a train coming the other way, as you do on a single working branch line, you don't want this signal to go to clear when you go over this detector, because you've got a train on here. You don't want that going clear because it's going that way, not that way, and that would look, well, extremely silly apart from anything else. So my cunning plan is about how to stop that signal clearing when the train goes that way, but clearing when it goes that way. And having spoken to Clive at Heathcote Electronics, what I'm going to try is one of these. This is an IRDOT 3D. Again, full information about this product on their website and all the details on how it works. I'm going to use it for a purpose that I don't think Clive originally designed it for, but nevertheless, I'm hoping it will work. Now this one, roughly how it works is, again, the train is detected by the sensor in the track, the same as the Semaphore sequencer. And what it does is, this little grey box here, I think it is, it's got a couple of relays in, and it triggers that relay. And when it triggers it, the relay shuts. So when you've got a train over it, the relay shuts. And when that shuts, then the signal won't work. And the reason for that is, for example, if you've got a train coming down this track, and the points are against the signal. So you've got a train coming this way and you've got the points against it. You can put a switch on the points. If it's Pico, you could use the Pico PL, I think it is 13 accessory switch. If not, it's one of the accessory switches. And that switch purely connects onto the Semaphore sequencer, onto terminals A and C, there's that and that one. And that in effect switches the unit off. If that creates a circuit through a switch or that switch, it stops that sensor from reacting. So my plan is to put this one in between the signal and that sensor. So you have another sensor about here. So when the train comes this way, this relay will shut, in effect, shutting down this sensor. So the signal won't work. Two other little bits of information here. First of all, when the train comes this way, it triggers the sequencer first. And as soon as it's done that, the timer starts. And it doesn't matter that it will go over another sensor here from this one, because it's already started, the signal will have changed and the timing sequence will have started, and that can't be altered. When it's coming this way, the train will hit this first, so by the time it gets to the Semaphore sequencer, the circuit will already have been closed and it won't work. This is my master plan. A clever bit about this is the D version. D stands for delay. And you can wire this so you have a choice of delays from 3 to, I think it's 15 seconds. I will consult with the instructions. Very comprehensive instructions with the stuff from Heathcote. And it will tell you in here how to adjust the timing. But I cannot remember. Oh, 24 seconds maximum delay. But you can choose it what is convenient for you. The reason you need a delay is that when the train goes over that sensor, which will be about here, you'll get gaps between the coaches and or trucks. And it is possible that the sensor will miss them. And it will see clean air. And as soon as it sees clear light, the relay will open again, which will enable that sensor to work. So you could have that sensor working again when your train's halfway across. But by building in a delay, that won't happen. It won't see the gaps between the coaches. And I will probably use the 24-second delay, by which time the whole train will have disappeared, and that'll be fine. The delay on the signal closing again, the adjustable one on here, again, you can set it to your own convenience of how long you would like it to work. I think it's up to 30 seconds or something, or maybe it's 60 seconds. Anyway, it's in the instructions. I need that to be quite long because on my layout, where I'm going to put this, the distance from this detector to the signal is going to be about 6 or 7 feet. And the reason I'm doing it that way is, in normal circumstances, trains don't get right up to a home signal which is at danger and then it suddenly changes. It would normally be slowing down or stopping. But if you trigger it 7 foot away, it looks more realistic. Well, that's my opinion. So, this is the master plan. And as I said, I'm not going to show you how to actually fit these or wire them up. Don't need to, because if you go to Heathcote Electronics website, there is full instructions and full details. All I'm doing here is telling you about the theory of my cunning plan, and then I'm going to fit it and see if it works. If it doesn't, I will look a bit of an idiot, but that is the plan. So The next bit of the video will be hopefully this all in place and see what happens. Well, hello and welcome to underneath my baseboard, and the snake pit is the wiring under it. And you can see here the two units in place. They're fully fitted with the sensors in the track and up and running. Now, I said at the end of the last clip that it'll either work or I'll look extremely stupid. Well, I have to say the second of those two things has happened. It doesn't work, and it is largely through my stupidity, which is the bad news. The good news is I can see why, and I think I've come up with a fix for it. The reason it didn't work is because I didn't RTFM. In fact, I didn't RTFM properly. And the bit I missed in the instructions was, here is the connections for the relay on the IRD OT3D board, and I've got them going to connections A and C, so when this one is triggered it stops that one operating. But what I didn't read in the manual was that it delays it. A train comes over, when that is switched shut like that through the relay, a train comes over, the sensor sees it and it doesn't change the signal because that is shut. But what it does do is, after the delay has happened on this board, this LED lights up when it's sensed and it's on delay. When it goes out, this one says, oh, it's clear now, and it works the signal. So all I've in fact done is built in a delay to the system. And I will just fire it all up and I will show you what's actually happening. The LED on this board, bring it into the shot a bit, that LED flashes when, first of all, it senses a train and it blinks for the time that the timer is running, i.e. it flashes, the signal clears, it blink, 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 blink through the timing period, and then it goes out. So I'll just show you what was happening on that. Okay, here we go. I've got a Class 8 shunter up on the track above, so we'll send it over. This is coming back through the signal, so this is when we don't want the signal to actually fire up. So hopefully it will move shortly. It will go over the sensor for this board, which will light that LED. Then it lights that one. This one goes out. That one starts blinking. And that means that it's on its timer signal. I've shut the timer period right down just for demonstration purposes. So you can see that one lights up, that one flashes, and then when that one goes out, the signal goes. And that is the problem we've got. And I need to, let's turn the sound off of that shunter noisy thing. And that's the issue we've got to solve. My plan, and don't do this at home, is here are the cables. I said in the first clip that I've got the extended wire version, so the infrared detector is not on the board, it's on the end of a long wire. What my plan is there are 4 wires going to the detector. There's the emitter and the receiver, and each has 2 wires. My plan is to remove this wire going to A and C from there, remove that completely. This is on terminals A and B. I think it's A and B here. And that means that when that is triggered and it lights up, that makes a connection. So in its normal state, it's not connected, the switch is off, and when the detector goes, it's on. I'm going to move those to the next 2 along, and the relay state then is when it's not detecting, when it's normal, the switch is closed, there is a circuit. So I'm not going to move the wires, I'm going to take them out, but I'm going to use the next 2 terminals. And what I intend to do is cut one of the wires on the sensor and run it through that relay, so that in normal state the emitter and receiver are working perfectly normal, but when that light is on, i.e. it's triggered, it will disconnect one of the wires to the sensor. And my plan or assumption is that means the sensor won't work, so that board will not know what's going on and will not do anything. When that timer comes off, when that light goes out, it will restore the connection and that one will work again. That's my plan. I would reiterate that the use I'm putting these boards to is not what they were intended to do. And by cutting that wire and doing what I'm doing, I am fully negating any warranty I might have in these parts, because it's not what they're designed to do. But if I can get it to work, I think I'll be ahead of the game. Okay, I will make that modification and let's see what happens. Right, made the modification. I've got the Class 8 ready to come along, so we'll wheel it along and see what happens. Right, that was perfect because that was coming towards the signal, so it fired the signal and the relay connection made no difference to the operation of the signal. That's fine. Now for the proof of the pudding, it's got to come back down through. And what we want to see when it comes back down through is we want to see this one light up and this one not. So let's see what happens. Hold your fingers, cross your fingers. Woohoo! Result, it works. Superb. I don't think I've done any damage to anything. This relay, by the way, will handle 5 amps, so that's not a problem. I think what I'll do now is get up top and make a video of it actually working, so you can show that the signal actually works as well. But at the moment, I'm calling it a bit of a result. Right, here we are up top, and over here are the sensors in the track. That is the signal sequencer one, and that is the IRDO T3D, which is the relay to stop that one working on the way back down. So what we'll do is we'll send a train up and then bring it back again and see what happens. The track, as I said, is a fair way away from the signal, and the signal is at the tunnel entrance. I haven't finished fitting that properly yet. I couldn't fit it up at the same level as the track because it poked well up over the air over the tunnel. What I'm going to do is put a little wall around it and build a false ground in it, so it looks as though it's on the same level with the track, but that's cosmetics to happen later. Okay, back at the business end, we'll follow the train up through the signal and see what happens. It's the trusty old Dapol mogul. That all went swimmingly well, just as predicted. The train has been out to the branch line terminus, run round it, the loco's run round its train, it's on its way back, should be here very soon, hopefully, and let's see what happened to its signal. Hopefully it shouldn't do anything. Well, it's gone off it to the station, it's gone over the detectors and nothing happened. Result, very happy with that. So there you go. I don't know what I'm going to do next. Oh, I know what I'm going to do next. I'm going to do something similar with the branch line terminus signals. But for today, that's it. Thank you very much. Bye.